Hello. Okay. So very good morning everyone and welcome to IFAS guys. Good morning to all of you. Okay. Uh, Good morning, very good morning guys. Okay. Just connect everyone, just join the session as soon as possible and soon we shall begin our session. Okay. This session is specially focused for HP set as well as AP set. But if you are targeting other exams, this session will also be helpful for those exam as well. Because a question is a question. Okay, it can come which exam it may be possible. Okay, it can come in HP set, it can come in AP set, it can also come in your net June 2024 examination. Okay, for every exam this is most likely this will be the series that will help you to come across such questions. Okay, so if you are attending this question, this will be if you are attending this session will be helpful for any of the exam that you want to target. Okay, not just HP set, not just AP set. Okay, we are, yes, primarily we are targeting HP set as well as AP set, but you can target other exams as well. Okay, so very good morning to everyone, those who have joined the session. Just let me know, am I clearly audible as well as visible? Once, just confirm it. Okay, so Payal has joined the session. Good morning sir, very good morning Payal, how are you? All clear sir, thank you so much Payal. So let us get started. Okay, let us begin the session. Okay, so in this session we are targeting so many questions that if you attend these sessions, okay, your inorganic concepts will become much more clear as well as stronger. Okay, the concept will uh, be more clearer to you. Okay, if you solve this question. Okay, so let us start the session guys. Okay, this will be the first question. Okay, this will be the first question that you want to target. Okay, so tell me what will be the respective reaction product. Okay, Madhav, hi sir, good morning. I wanna know about GRF certificate, any update? Okay, so I don't think any update has come regarding this. If there was any update at all, we would have informed you. Okay, so just subscribe to this channel. Okay, so whenever any possibility seems or whenever any notification comes out, we will let you know about that. Okay, so this is going to be our first question guys. Okay, what we have taken is we have taken A, B, C products, okay, from the following reactions. The first reaction is BF3 and NS3 reacting, and the second is B2H6 plus H2O, that gives B, and the third reaction is B2H6 heated at 100 degrees Celsius in the absence of air. Okay, so what might be the product guys? Yes, so let us be specific. Okay, let us be specific. I will take here high temperature. Okay, this is very crucial, so that you should mention here high temperature. But otherwise, if it's low temperature, you will get a different kind of product. Okay, a different product at all. So that is why it is very crucial to mention the temperature of the reaction, because at low temperature there is formation of a different kind of product, and at higher temperature the product seems completely different. Okay, so let us take the first reaction. Whenever I take BF3 as well as NS3, what happens here? Here at high temperature, formation of boron nitride takes place. Okay, and instead of high temperature, I write it as very high temperature, around 1000 degrees Celsius, 1500 degrees Celsius, 2000 degrees Celsius, as well as high pressure. I will take high pressure as well. So whenever you take these reaction conditions, there is formation of BN, that is boron nitrate, which is isomorphic. Not I should not use the word isomorphic, rather than I should use the word isostructural. Okay, or analogous with your graphite. Okay, this seems like graphite, but there are certain differences that exist. Okay, so the next reaction B2H6, when we take it with H2O, what happens here? Whenever we take B2H6 and H2O are reacted, formation of what happens? Formation of H3BO3 takes place. H3BO3, and along with that you will find that the byproduct, this is also very important. Okay, byproduct is also very important, because whenever I take B2H6 and if I react it with your H2O, formation of H3BO3 plus H2 takes place, and when I react with oxygen, there is formation of B2O3 plus H2O. Okay, this kind of question is has been asked in your net examination. Okay, CSIR net examination, this question was seen. Okay, so the next reaction is B2H6 heated in absence of air at 100 degrees Celsius. So whenever I heat B2H6 at 100 degrees Celsius in the absence of air, what happens? Yes, so there are n number of B2H6 here. Okay, whenever I heat this in the absence of air, what happens? The number of boron atom per molecule increases. Number of boron atom as well as hydrogen atoms increases per molecule, and formation of B4H8 can takes place, B6H10 can takes place, B6H10, B8H14. So this kind of higher boranes are formed. Okay, higher boranes are formed. Okay, so therefore option 4 is going to be your correct answer. Okay, option 4 is your correct answer, and Payal has exactly given this answer. So very good, Payal, very good. Okay, so let us hop on into the next question, guys. Okay, what is the charge on the silicate ion? Okay, so it is very interesting thing. Okay, I want to tell you one thing, that whatever might be the question, whatever might be the sessions we are targeting, but if we are targeting other exams as well, yes, especially if you are targeting CSR net, okay, these questions will be helpful for those session as well, those exams as well. Okay, because is a question is a question. It can either come in your set examination, it can either come in your jam examination, it can either come in your net examination, as well as different kind of exam. Okay, a question is a question, the possibility exists. Okay, so just let me know the answer of this question. Okay, please try to solve this question. Very good, Pile. A, option A is going to be your answer. Okay, so let's confirm whether A option that you have selected is correct or incorrect. Okay, so now it is very easy, guys. This question is very easy. Okay, this can come for 2 marks in CSR net as well. Okay, and in set it is obvious that every question is for 2 marks. So now the silicon that can exist in +4 oxidation state, and it has 2 silicon per molecule. Okay, and your oxygen has -2 charge, and there are 7 oxygen. Okay, so this gives 8, this gives 14. So minus, what happens here? Minus 6 happens here. So option C should be your correct answer. Yes, option C should be your correct answer. Okay, so I think there was a little bit of confusion, but hopefully everything is sorted now. Okay, and if you are having any doubt, please let me know. Okay, so let's move on to the next question, guys. Okay, okay, solve this question. Okay, identify the acids in the following 2 reactions. Okay, you should tell the acids, which are the acids that are present in these 2 reactions. Yes, although the answer is marked here, but don't worry about the markings. Okay, either it can be correct or either it can be wrong. But from this question, what you need to do is you need to learn the concept. Okay, so please focus on the concept rather than coming to a result or coming to an answer. Okay. Yes. What will be your answer, guys? Just let me know. A. Very good. Very good. Okay. So now let us try to solve this question, guys. Identify the acid. So now what is an acid, sir? Yes, what is an acid? So an acid is an electron deficient species which can accept electron density, which can accept electron density. Okay, that is called an acid. Okay, so usually what happens here, sir? So usually you can see the first reaction. This is my first reaction, this is my second reaction. In reaction number 1, you can see NOF is present, in which NO is having positive charge and fluorine is having negative charge. That is called as fluoride. Okay, so whenever a species or fluorine is having negative charge upon it, that is called as fluoride. So now this is my ClF3. Okay, so now this ClF3 has vacant orbitals, and specifically vacant d orbitals, where it can accept electron density. Okay, so therefore it accepts the electron density along with that of fluorine. Okay, so fluorine will come with its electron density and ClF3 will accept that fluorine. So that's why this is called as an halide acceptor. Okay, this is called as an halide acceptor. Okay, so here you can see it is accepting an halide. So that's why this is accepting indirectly the amount of electron density that is present on fluorine. Okay, so that's why this is going to be the acid in first reaction. And in second reaction you can see obviously that OH minus, it is a form of base, NaOH, KOH, LiOH. Okay, so here what happens, XeO3 is accepting this kind of base. So therefore for this reason XeO3 will be the acid. Okay, so for that reason option A is correct. Okay, next question. This question is also very simple as well as very interesting question. Okay, you need to use your brain. Okay, so what will be the answer? It's going to be a very interesting question, guys. Yes, just let me know. Okay, so I'll give you an hint. Okay, I'll give you an hint for this question. See, P4O10, you have been given P4O10. What is the structure of P4O10? Yes, this is going to be the structure of P4O10, where there are phosphorus. Okay, these are phosphorus, and there are also oxygens. 1, 2, 3, 4, 5, 6. Okay, so this is P4O6. So now what happens here, guys? If I take 4 additional oxygens per molecule per phosphorus like this will be the P4O10. Okay, this will be P4O10. Now you have been asked for 1 mole of P4O10. How many number of moles of H2O is required to complete this reaction? Okay, Varsha has said that D is going to be the answer. Very good, Varsha. Payal is saying A is going to be the correct answer. Very good, Payal. Okay, so there is an, I can say, different opinion about this reaction. Okay, we'll let you know. Okay, Chem Pacific has joined the session. Shubh Prabhat Sarji, happy Gudi Padwa. Thank you so much, Chem Pacific. Very good morning to you as well, Suprabhat. And to all the viewers present here, happy Gudi Padwa to all of you. So now if I take one molecule, okay, HO, this will be the breaking. Okay, if I take another molecule, H2O, I will write like this. Okay, no. Here, H2O, O, H2. This will be the breaking. Okay, one more. One. Okay. So I'll just simplify this reaction. Okay. So if you see here, there are how many POP bonds present? Yes. For one POP bond to be broken, you will need one molecule of what? One molecule of H2O. So that what happens here? So that you will get P double bond O like this. Okay. So for 6 POP bonds, okay, there are 6 POP bonds. What you need is 6 H2O molecule. Okay. So for 1 mole of P4O10, you will need 6 mole of waters. Okay. So therefore option 4 is going to be the correct answer. Okay. Option 4 is correct answer. Yes. Very good, Payal. How's Rao Shinde? Good morning, sir. Very good morning. How's Rao? How are you? Okay. So let's go to the next question. This question is also very interesting. Okay, you have been asked CuI twice is unstable because it readily decomposes to what? Yes, just let me know the answer. CuI is unstable. So it will decompose. Okay. And after decomposition, what will be the product? Yes, what will be the product? Okay, very good, Pile. D option. Okay. Chem Pacific has also said D is going to be the correct answer. Muhammad D. Payal D. Varsha D. Okay, very good, guys. Yes, Chem Pacific. I think today we are going to discuss MS set. Okay, we will inform you. Okay. So, CuI twice, that is copper iodide. Okay, it is unstable. This is unstable. Okay, so therefore, what happens, Sarji? Say, therefore, it decomposes. Okay, it decomposes into what? It decomposes like this. Okay, if I take two molecules of CuI2, what happens here? If I take two molecules of CuI twice, okay, it decomposes into CuI plus I twice. This is going to be the reaction. So therefore the final product for this reaction is what? The therefore final product for this reaction is from option 3. Okay, so therefore option 3 is going to be your correct answer. Okay, so if it's there any doubts, please let me know. Okay, and let's move on to the next question as well. Okay, so this is going to be your next question. Okay, just let me know what is going to be the correct answer. All of you try this question. AKR chemistry. Hi, sir. Hi, AKR. Very good morning to you. Sheetal. Good morning, sir. Very good morning, Sheetal. How are you? Okay. Option C. Okay. So let us try this question, guys. I am fine, sir. And you? Yes. I am also fine, Sheetal. Thank you for asking. House Rao Shinde is saying option D. Chem Pacific C. Okay, first of all, those who are present here right now, just once like the session, guys. Okay, who has not the like session till now, just make sure you hit the like button. Okay, and share as much as possible. Okay, Varsha C, Chem Pacific. BHB 3 center 2 electron bond. Payal C. Mohammed C. AKR chemistry C. Okay. Seems like this is an easy question for you. Okay. So let us know what is going to be the correct answer. Okay. Vasu Mitra has also joined the session. He is saying option C is going to be the correct answer. Very good, Vasu. Okay. Let us confirm. In diborane, there exists a direct bond between boron and boron. First of all, see, it is a very easy question. If only you know the structure of B2H6. What is the structure of B2H6? BHB. Okay, so there are two boron atoms which are connected with the help of hydrogens. And for every boron atom, there is what? There is two terminal hydrogen present here. Okay. Okay, so this is going to be the structure. So now there exists a direct bond. This is incorrect statement. All the atoms are in one plane. Yes, is it correct? No, definitely not. This is also an incorrect statement, because if I take this as my plane, okay, I'll take this here so that all of you can see this. Okay, so this is my plane. Okay, so in this plane you will find borons and these terminal hydrogens, but those two bridging hydrogens are present above the plane as well as below the plane. Okay, this is going to be the structure. Okay, so now yes, this is also incorrect because these two atoms are outside the plane. Okay, the number of electrons in BHB is formed by 2 electrons. Okay, yes, this is going to be the correct statement. So because if you see here, this is having, yes, how many electrons? Because here we are having 1, 2 and 3 center, and in between these 3 center you will find what? This 3 center will contain 2 electrons. So that's why this is called as 3 center 2 electron. Okay, the number of electron in BHB is formed by 3 electron. This is going to be the incorrect statement. So therefore option C is going to be the correct answer. Okay, so what is the point group? Yes, before asking this question, yes, I wanted to ask the question right after explaining these options, that what is the point group. But before asking, all of you have suggested that this molecule will have D2H point group. Very good, guys, very good. Okay, this will have D2H point group. Okay, so there are total 3 center 2 electrons. And if I ask regarding 2 center 2 electron, how many number are those type of bonds are present? Yes, how many 2 center 2 electron bonds are present? Just let me know. Okay. Yes, Muhammad, very good. Very good, Muhammad. Okay. 4 is going to be the correct answer. Okay. No. AKR chemistry. Option 4. Okay. 1, 2, 3 and 4. Okay. So there are 4 2-centered 2 electrons present here. Okay. So let's move on to the next question, guys. Okay. So these are very good questions. Okay. The self-indicating silica gel impregnated with cobalt chloride. Okay, you have been given cobalt chloride turns pink on absorbing moisture and becomes blue on heating. The pink and blue colors are respectively due to what? Yes, very good question. Yes, uh, I just feel that this question is very good. Okay, because this has an practical application. Yes, you are taking silica gel which is impregnated. That means it is added with cobalt chloride. Okay, so on absorbing moisture, it becomes pink, and on heating, it turns itself into blue color. So here I am seeing that Muhammad Varsha and Vrindavan Dham 4 is their answer. AKR chemistry is suggesting that option 2 is going to be the correct answer. Varsha has said option C is correct. Very good. Okay, and I want two things from you: more answers and more likes for this session. Okay, so just try, every one of you that is present here, please try as much as possible, as well as those who have still not liked this session, please once hit the like button. Okay, Sheetal is saying option C is going to be correct. Very good, Sheetal. So now let us solve this question. Okay, I have silica gel, guys. Okay, this is my silica gel. Okay, this is what? This is my silica gel. Okay, so now this is impregnated with cobalt chloride. So now what is the yes, what is the molecular formula of cobalt chloride? COCl4, and it is having two negative charge. Okay, so it is containing what, sir? It is containing COCl4, 2 negative. Okay, this contains COCl4, 2 negative. Okay, so now what happens here, sir? Whenever this absorbs moisture, okay, moisture is in the form of H2O. Okay, so whenever this absorbs moisture, here what happens? Here these two will react and we obtain a product like this, plus H2O. This forms the following product: H2O by 6, 2 positive. Okay, so therefore there is a formation of what? There is formation of COH2O by 6, 2 positive, and this will have pink color. Okay, pink or light pink color. But whenever you heat this, sir, what happens? The molecule will get converted into this. Okay, COCl4, and this will have blue color. Okay, this will have blue color because on heating all the H2O gets evaporated, and all that you are left with is cobalt as well as chlorine, which together forms COCl4 once again. Okay, so from this I can say that option C is going to be your correct answer. Okay, and you can find a practical application of the color of your coordination complexes. Okay, here octahedral complex is being formed, and we know that octahedral complex are having what? DD transitions, which are Laporte forbidden as well as spin allowed. This is Laporte forbidden and this is spin allowed transition. Okay, so therefore for this reason what happens? Yes, this is having a light color which is less intense. But if you see here, this is an tetrahedral complex. In tetrahedral complex, this is having what? This is having, sir, yes, this is having DD transitions, and this DD transitions is having certain PD mixing. That means this is Laporte partially allowed as well as spin allowed transition. So therefore tetrahedral complex are more intense comparatively to that of your octahedral complex. Okay, and for that sake option C is going to be your correct answer. Okay, yes, this was a very good question. Yes, I think you also will say that this question is very interesting. Okay. Okay, so let's move on to the next question. This is going to be your next question. So tell me, what is the correct answer for this question? You have been asked the increasing order of the observed infrared IR mu CO per centimeter among the isoelectronic complexes will be. Okay, so what will be the answer? I feel that this question, everyone present here will answer this question very easily and that too correctly. Okay, Vrindavan Dham, D is correct answer. Payal is saying B. Hausrao Shinde is saying A. Okay, so there are differences in the answers. Okay. Okay. House Rao, okay, A. Varsha is saying A is going to be the correct answer. Very good. Yes, all of you just answer this question. Okay, so let us solve this question, guys. Okay, the increasing order of the observed infrared IR stretching frequency among the isoelectronic species is. Now we know that if positive charge increases, yes, if positive charge increases on the metal, what happens? Back bonding decreases. Yes, back bonding decreases, carbonyl stretching frequency will increase. And if negative charge increases, back bonding increases and carbonyl stretching frequency also increases. Okay, so for that sake the highest stretching frequency will be observed for a molecule or a complex which is having positive charge, that is MnCO by 6 positive. Okay, and the next one will be a neutral species. Okay, so for that sake, first of all, let's eliminate two options. Right now we are left with two options. Okay, further two options are left. So in these two options, then will come what, sir? A species which is having a neutral charge. Then will come a species with a negative charge. So therefore, for that sake, option A is going to be your correct answer. Okay, option A is correct, guys. Okay. Okay, let's move on to the next question. Okay, one more question on silicates. Yes, because silicates is very important, guys. Silicates is very important. Yes, just let me know what is the correct answer for this. Yes. Okay. So let us solve this session. Let us solve this question. Okay. Pyrosilicates are the silicates in which the two tetrahedral units are linked at how many points? Okay. So there is a confusion for Vrindavan Dham. Maybe one. Okay, so there are different kind of silicates: orthosilicate, pyrosilicate, metasilicate, sheet silicate, 3D silicate, tectosilicate, amphibose. They are also known with different names as well. Okay, so if we talk about pyrosilicate, pyrosilicate. So in this pyrosilicate, what happens, guys? In this pyrosilicate, you will find two SiO4. Yes, this is one SiO4. That is basically an ortho unit. And this is another SiO4. So these will two, what will do this, sir? These two will join together. Okay. So whenever they are joining, one oxygen is eliminated. And you will find a structure like this: oxygen, oxygen, and oxygen, 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 and oxygen. I don't like it, I avoid, but silicon likes oxygen, it can't avoid. Okay, so therefore this is going to be your molecule, and these two species 1 and 2, these two tetrahedral units are connected at a single point. Therefore option B is going to be your correct answer. Okay, option B is correct. Okay, let's hop on or jump into the next question. Which one of the following molecule doesn't obey the 18 electron rule? Yes, so now there is an application of 18 electron to this molecule. Just supply 18 electron. Whichever is falling, that is fine. Whichever is not falling, that will be your correct answer. Okay, option D. Okay, good, very good, guys. So just now we have seen that this is an 18 electron complex. So therefore there is no doubt. Okay. So this is having 7 electron. This is having 12. And minus 1 for positive charge. You will find 18 electron here. Okay. In this complex 8 plus 10, that gives me how many electrons? 18 electrons. CrCO by 5, 2 negative. Yes, what happens here, sirs? Chromium has 6 electron. 10 electron will come from 5 carbon. And additionally 2 negative charge. That means this is also an 18 electron complex. Yes, 7, 8, 2. Yes, this is having 17 electron. That's why option D is going to be your correct answer. Okay. Okay, next question, guys. Question. I don't like it. I avoid. Plus, question likes me. I can't avoid. Vrindavan Dham, sir, please explain to last question again. Request. Okay, which one, Vrindavan? Yes, I think this one or this one. Yes, regarding stretching frequency or regarding this silicate. Okay, just let me know. I can then explain the following question. Yes, this one. So, which one? Yes, regarding silicates. You tell me, either you can type silicate or IR. I will know. Okay, back bonding wala. Then that means this question. So this is also very easy question. See, here it is my metal and this is my carbonyl. Okay. So what happens here if the metal is having additional charge? So right now I can say that the metal contains a negative charge. What happens, sir? Yes, it is already the metal is having already some electron density present in its orbital. So now due to negative charge, it gets filled with more negative charge or more electron density. And metal is kind of a species which is electropositive in nature. It cannot handle negative charge, okay, because metal is electropositive in nature. So that's why the metal wants to remove its electron density from itself. Okay, so what happens here? Here it finds a local uh, orbital of carbon or carbonyl, okay, which is pi star anti-bonding molecular orbital. Okay, this is pi star anti-bonding molecular orbital. So now this donates the electron density in the carbonyl. This donates the electron density in the carbonyl. So therefore what happens here, sir? Yes, electron density gets accumulated in the pi star anti-bonding molecular of carbonyl. Yes, and whenever we say that the electron density gets accumulated in pi star anti-bonding molecular orbital, bond order decreases. Yes, bond strength decreases, bond length increases, and if we talk about bond strength, if bond strength decreases, carbonyl stretching frequency also decreases. Okay, so that is why negative charge accumulation leads to a lesser stretching frequency, whereas positive charge present on the metal leads to lesser back bonding. Back bonding gets cancelled, guys, because electron density is less. Okay, so back bonding decreases. So therefore for that reason bond order increases, bond strength increases, and stretching frequency also increases. Okay, so hope you find this explanation right and understand this. Okay, so now yes, we were talking about this question. NiCl twice pph pph thrice whole twice is paramagnetic with mu effective equal to 2.9 Bohr magneton. All the four ligands are monodentate. The geometry of the molecule is, yes, what will be the geometry of the molecule? Yes, it is going to be tetrahedral. Why? Because if you see here, nickel is present in plus 2 oxidation state. Okay, Ni is in plus 2. Okay, so I have what? D8 configuration of nickel. 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be the picture of electrons present in the orbital, okay, of nickel. And here we find S and here we find D. Okay, so this is going to be sp3 hybridization, that means tetrahedral arrangement. Okay, why we are taking sp3? Because you have been said that mu effective is 2.9 Bohr magneton. Indirectly they are saying that in d orbital it contains two unpaired electrons. So that's therefore for that sake here you will get what? N equal to 2 and mu equal to 2.9 Bohr magneton, and this is paramagnetic. But if there was an pairing of electron, this would have been given us dsp2 hybridization, and this would have been a square planar molecule, which is not the correct one. Okay, so therefore option D is correct, that is the molecule will be in tetrahedral geometry. Okay, next question. CrH2O by 6 3 positive is violet, and whereas CrNH3 by 6 3 positive is yellow. The wavelength absorbed by CrNH3 by 6 3 positive as compared to that by CrNH3 H2O by 6 3 positive, in their absorption spectra will be higher, lower, same. This complex will not show any absorption in the visible region. What is going to be your correct answer, guys? Yes, this question is also very interesting as well as beautiful, because it relates with electronic spectra, color theory, absorption, splitting. What is the thing that you will cannot relate with this? Okay, you can relate with many things. B. Okay, so we have answers. Very good, guys. Varsha, Vaishnavi, Sheetal, BBA. Seems like you have got a degree, BBA. Okay, if there was an option M, you would have made MBA as a degree. Okay. Okay, guys. So let us solve this question. CrH2O by 6 3 positive is violet. Okay, it's violet. Okay, and this is yellow. Yes. What happens, sir? Yes, you are having same kind of metal. Okay, CrNH3 by 6 3 positive. Okay, this is an weak field ligand and this is an strong field ligand comparatively. So therefore what happens here, sir? Therefore the splitting here is less. Okay, instead of showing less, I have shown this as more. Okay, delta naught is less. Here what happens, sir? Here the delta naught value is very large. Yes, large. Okay, so therefore, yes, what happens here? You will use artist wheel. VBGYOR. Okay, so here if the complex H2O by 6 is violet, that means this absorbs yellow color. Yes, and it absorbs, this is yellow, that means it's absorbing violet color. Okay, so now what happens, sir? You have been asked the wavelength absorbed by NH3 as compared to that of H2O is, yes, lesser wavelength. So option 2 is going to be correct answer. Okay, we have got violet and yellow. Yes, the violet is having higher frequency and lesser wavelength. Yellow is having lesser frequency and higher wavelength. So that's why like this should be in terms of wavelength. Okay, violet is having lesser wavelength. Okay. Okay, so this will be your next question. Okay, and this is going to be your homework question. A complex of certain metal ion has a magnetic moment of 4.90 Bohr magneton, and another complex of same metal ion in the same oxidation state diamagnetic. The complex is octahedral. The central metal atom could be one of the following. What is the metal ion present here? And this is going to be a homework question. Okay, and I want every one of you answering this question in the comment box after solving this question, right? Not right now. Okay, so this is going to be a homework question for you. Okay, so please try to solve this question. Okay, yes, take a screenshot of this. Okay, take a screenshot, and I can give you a one more question. Okay, I'll give you a question this as homework. Okay, take screenshot of this as well and try to solve this question. Sheetal Mahavar, daily class time. Sir, daily class time. Okay, so the class starts from 8 a.m. in the morning. Okay, the class will be from 8 a.m. in the morning. Okay, so therefore, please be present, everyone, at 8 a.m. Okay, and just subscribe to the channel once. Okay, if you have not subscribed it to yet, because whenever the class gets started you will get notified. Okay, so hopefully you have taken a screenshot of this question as well. So now let's conclude this session, guys. Okay, let us conclude this question, session. Okay, so thank you so much and happy learning to all of you. Okay, if you have any queries, any doubts, okay, feel free to contact us with comment box, or else you can call this number as well as visit the website www.ifasonline.com. Okay, it was a very good session. I enjoyed a lot with you guys, and thank you so much for coming in this session, and happy learning.